think this is the last thing I'm going to show you on how to take a derivative. So once we get through this, I'm pretty sure you can take the derivative of just about anything that you come across. This is going to be the longest one. So let me just kind of get you started by saying, think about, and by the way, we're on 4-4 day 2, think about how you would go about starting the derivative of this function. I'm thinking quotient rule. Are you thinking quotient rule? Now, the quotient rule doesn't start getting awful. I start out low, 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 and then I got to do the derivative of the high. That's going to be awful. Couple that with the fact that it's in a huge fraction, it's going to make it even worse. And then I have to try to simplify that. Oh my goodness, I can't even imagine how many kittens would be killed and how many mistakes would be made and all that stuff. So, good news is I'm going to show you an alternate method to take the derivative. And it's going to be better than doing quotient rule. The bad news is it's going to take most of your paper. But keep in mind, when I go through the notes, I'm showing you every single step. And we'll do many steps. But once we're all finished, I'll kind of, I need to remember to go back up and talk about, all right, now that you remember this, you're probably going to want to skip this step. But it's my job to bring up some things from pre-cal that you might have forgotten. So we're going to go through the process step by step. All right. It's called logarithmic differentiation. So instead of using quotient rule, I'm going to use logarithms instead. And even though it's set up really great for just taking a derivative, and, like the y is all by itself. So if I did a derivative, I just would go y prime equals, or dy dx equals. I'm going to change that. I'm going to complicate it even more than it is first. So I'm not doing any calculus yet at all. I'm going to do some pre-cal on this function. Logarithmic differentiation. So the first thing I'm going to do is I am going to natural log both sides. It's totally legal. I'm going to natural log both sides. I natural log that side, and I natural log this side. You thought it looked complicated here. Look what we just did to it. It's okay. It's going to get better. Look what else I just did to it, though. Now my y is not by itself, so I can't just do this and go, oh, the derivative is y prime. Nope. Remember, x is our variable. What is y? Y is that big old messy function. Let me just remind you, y is messy. So when it's time to do a derivative over here, I've got to do my derivative and then follow it up with the chain rule, remembering that y is messy. All right, so here's the reason I did this. I don't want to, I don't want to do the derivative yet. Think about what would happen. This is messy, right? If I did the derivative of natural log of messy, I would write 1 over messy times the derivative of the messy. Well, holy cow, I'm still going to have to do the quotient rule. So we are not doing the derivative yet. Okay, so remember back in pre-cal, we have expansion and compression. So what I'm going to have you do is we're going to take this one complicated logarithm that has multiplication in it and division in it, and we're going to expand it. So if you recall, this is division. This is division, and division can be expanded into two logarithms using subtraction. So I can expand. This is going to be its own logarithm with subtraction. I can also expand multiplication with addition. So I've got natural log, and then I'm going to have, I've got all this. I'm going to split it up. I'm going to go natural log of this piece. I'm going to go natural log of this piece, right? I'm expanding them with addition, and I'm going to go natural log of this piece, and I'm going to expand that with subtraction. And hopefully you are going to remember doing that in pre-cal. So now I've got natural log of this piece plus natural log of this piece minus, remember your pre-cal expansion rules, natural log of this piece. Okay, so when it's time for me to do a derivative, think about this. This was quotient rule. It's going to be awful. Now I have three separate terms. I can do derivative on each piece. But wait, we're not quite ready yet. You can simplify this even further. Bring your exponent down to the front. Bring this exponent 1/2. Bring this exponent out to the front, and bring this exponent out to the front. I don't have to keep writing that. I'm going to go 3/4 ln x plus 1/2 ln x squared plus 1 minus 5 ln quantity 3x plus 2. Yeah, I think I will write that. Okay. Now, think about this. Coefficient. Oh my goodness, easy derivative. Coefficient, messy, but not a hard derivative. Coefficient, messy, still not a hard derivative. What do we got over here? Remember that y represents a messy function, okay? So now that I've got my huge logarithm expanded into all of its pieces, I've brought all the exponents down to the front, it's going to be easy doing, it's going to take up a lot of room, but it's going to be easy doing these derivatives. Here I go, ready? The derivative of natural log of messy is 1/messy times the derivative of the messy. How do you express the derivative of y? What will you write? Y prime. Right? 1/messy times the derivative of messy equals constant. Do your derivative. Oh, so easy. Constant. Do your derivative. Oh, hold up. Now this is messy. Okay, so I've got my constant. Let's do this derivative. I get 1/the messy times the derivative of the messy minus 5 coefficient times, this is messy. Ready? Do your derivative. 1 over the messy times the derivative of the messy. Okay, nothing I did there was hard. None of that was difficult. I know, it took a lot of room, but that's okay. You can handle that. All right, so let's see. I've got 1 over y prime, 3 over 4x. And then when I do at the next term, my 2's cancel. And 15. We need to solve for y prime. This is what we need to have all by itself. Get rid of this. So I want you to multiply both sides by y. So I'm going to come over here and go times y times y. But hang on. What do we know about y? I'm not just going to put times y. What do we know about y? We know what y is. That's y. Usually this is where I get a bunch of groans. Everybody's like, oh no, I have to multiply by that nasty fraction and then I have to, okay, yes, you have to multiply by the nasty fraction. No, there is no then I have to. We're just going to write it. We're just going to write like this 3-term expression times the original y function. That's going to be our answer. We're going to circle it and we're going to be done. So parentheses, 3 over 4x, x over plus 1, and 15 times the quantity, the yucky one. Final answer. I think that is way better than trying to do quotient rule. Now, it took me 1, 2, 3, 4, 5, 6. It took me 6 lines to do this problem. I don't think it should take you that much work. Let me think about what you probably are going to eliminate. So you need to show me where you're taking natural log of both sides. Okay? I think that once you get the natural log of this whole expression here, I don't think it's going to take you 2 lines to expand your logarithms. I did it in 2 lines because I wanted to show you the expansion and then the exponent movement. I think you can do all that in 1 line. Okay? So there knocks you down 1. Okay? We get this. You have a line for your derivatives. Definitely have a line for your derivatives. And then I truly think as you are simplifying, you're also going to multiply both sides by y. Okay? There was just no way that I would condense all of that into such I didn't want to lose anybody, so I didn't do that. Okay? All right. This concludes our notes for this unit.